Hey guys, welcome back. In this video, we're continuing to talk about properties of exponents, and we're going to look at some examples of the multiplication and division properties of exponents. So to start out, let's look at multiplication. So here I have 2 squared times 2 cubed. So you'll notice that 2 and 2, these are the same base. So I have a base raised to an exponent times the same base raised to another exponent. This means that I can rewrite this as 2 to the 2 plus 3, which is 2 to the 5th. So 2 to the 5th is 2, 4, 8, 16, 32. So I get that this is 32. But I want to kind of think about this problem and not just use the rule, but kind of think it through. So I know that 2 squared means that I should take the base of 2 and multiply it by itself twice, and that 2 cubed means that I should take 2 and multiply it by itself 3 times. So I'm going to replace 2 squared with 2 times 2 and 2 cubed with 2 times 2 times 2. So this becomes 2 times 2 times 2 times 2 times 2, which I'm now going to count these. I have 2 multiplied by itself 1, 2, 3, 4, 5 times. 2 to the 5th, that is 32. So this property checks out. So now that I've used it and kind of shown that it works, I'm going to come over here and I am going to look at this situation over here. So I have x to the 4th times y times x squared y cubed. Now we're keeping in mind that the bases need to be the same. So what I notice here is that I have x to the 4th and x squared. Those have the same base. And then I have y times y cubed. I'm going to be able to combine the things that have the same base. So this will become x to the 4 plus 2 times y to the 1 plus 3. Remember, because there is a y here with no exponent, it has an implied exponent of 1. So this gives me x to the 6 times y to the 4th. So that's my example for multiplication. Let's go through some similar examples, but this time for division. So I have 2 to the 5th over 2 squared. Using my division rule, if they have the same base, I can subtract. So I have a base of 2 and a base of 2. That means I should be able to make this 2 to the 5 minus 2, which is 2 cubed, or 8. 2, 4, 8. So let's think through it this way instead. So 2 to the 5th is 2 times 2, 5 2s, divided by 2 squared, which is 2 times 2. So that is 1. So I cancel that out. That is also 1. So I get 1, 2, 3, 2 raised to the 3rd, which is 8, and the division property checks out. Let's go over here and use this. Again, I have 2 different bases. So I have x cubed y to the 7th divided by x times y to the 4th. So x and x are the same, y and y are the same. So this is going to become x to the 3 minus 1. Remember, this x doesn't have an exponent, so it's implied as 1, times y to the 7 minus 4. So this is x squared times y cubed. And there we go.